Every skyscraper begins as an ordinary rock. And inside this rotating furnace, the temperature reaches 1450 degrees Celsius. This is where limestone becomes cement. Limestone breaks apart and recombines into glowing clinker, the white-hot heart of cement production. Every skyscraper, bridge, and highway begins with this fire. This is how ordinary rock becomes one of the world's most essential building materials. The impossible heat of the kiln begins with stone. Now the journey descends into the journey begins inside enormous limestone quarries. These vast excavations expose rock that formed beneath ancient oceans, millions of years ago. Massive hydraulic excavators load thousands of tons of limestone every hour. This raw material will soon begin a transformation unlike any other in modern industry. Specialized haul trucks transport freshly mined limestone from the quarry to the processing plant. Every load moves one step closer to becoming the foundation of future cities. The raw stone has been mined and moved. Next comes precision breaking. Before the rock enters the manufacturing process, enormous crushers reduce boulders weighing several tons into smaller, manageable pieces. Precision begins with size. The crushed limestone is blended and stockpiled in precise proportions. Chemistry and logistics meet here, long before the fire ever starts. Inside the raw grinding mill, rotating steel balls pulverize the stone into a fine powder called raw meal. Every particle must be uniform. The raw meal is ready. What follows is the most intense stage of the entire. Before the kiln, cyclone preheaters recover heat from exhaust gases. Efficiency is engineered into every stage of the process. The rotary kiln slowly rotates, mixing raw meal as it moves toward the flame. Inside, temperatures exceed 1400 degrees Celsius. The fire has done its work. The clinker must now be cooled, blended, and the red-hot clinker must be cooled rapidly to preserve its strength. Air rushes through the cooler as the material tumbles forward. A precise amount of gypsum is added to control how the cement sets. Too little or too much would compromise the final product. Inside the cement grinding mill, steel balls reduce clinker to a fine powder. What emerges is the gray material that builds modern civilization. Portland cement is nearly complete. Before a single ton ships, in the quality control laboratory, technicians test every batch. Strength, consistency, and chemistry are verified before a single bag leaves the plant. From the control room, engineers monitor thousands of data points in real time. One of the oldest industries on Earth, now run by software. The product is verified. Now it flows into silos and packaging lines. Finished cement is stored in towering silos, each holding thousands of tons. From here, it will travel to construction sites around the world. Automated bagging lines fill, weigh, and seal bags at remarkable speed. Each bag carries material that will become someone's floor, wall, or foundation. From robotic palletizing to bulk tankers, finished cement prepares for its journey out. Robotic arms stack bags onto pallets with mechanical precision. Human hands rarely touch the product after it leaves the grinding mill. For large projects, cement is loaded in bulk directly into trucks and rail cars. A single train can carry enough material to build an entire neighborhood. Every shipment carries the material that holds civilization together. At the construction site, concrete trucks arrive fresh from the plant. Within hours, liquid cement hardens into solid rock. From above, the scale of the operation becomes clear. A single plant can supply enough cement to build an entire city. Skyscrapers, bridges, dams, stadiums, and rail networks. All of it begins here, with fire, stone, and engineering on an industrial scale.